All right, the last just chain rule problem I want to do is going to be a word problem, because I think the word problems can be intimidating and can make it harder to kind of see like the parts you're supposed to pull out. And really the tough part about these chain rule problems is keeping organized what you need to pull out and put in your diagram. So I'm going to write out all the words in this word problem. So a right circular cylinder. That's just like a normal cylinder that's standing up and down like a Coke can, is changing so that its radius R increases at the rate 3 inches per minute, and its height is decreasing at the rate 5 inches per minute. At what rate is the volume changing when the radius is 10 inches and height is 8 inches? Okay, so that's a whole paragraph of a word problem, and we're going to try to figure out how this is possibly a chain rule problem. We know it's a derivative problem because we're learning about things changing, and we want to know what rate is the volume changing. So that's a question of what's the derivative of the volume. And since we're talking about rates and things changing in time, that derivative should be with respect to time. Oh, my AC just kicked on. So at what rate is volume changing is telling us find dV dt for volume V. And then let's go ahead and try to write out equations for the other stuff that we're told in the problem. We're told that the radius increases at the rate 3 inches per minute. So the radius is changing in time. So what they gave me was information about dr dt, how the radius changes with time, and they told me it's an increase of rate 3. Using kind of the same reasoning, height 8h decreases at rate 5 inches per minute. That's telling me they're giving me the rate at which h changes. So that means I'm thinking about change in h over change in time, dh dt. And it's decreasing. The derivative should be negative. As time goes on, h should get smaller. And the rate it happens at is just 5. Okay, so there's one more thing that I kind of need in order to finish this. I need to know what volume is. And that's just something that I would have to know to do this problem. So the volume of a cylinder is the base of the cylinder has area pi r squared. and then multiplied by the height of the cylinder times h. And so I want to find dv dt, but I have information about how v depends on r and h. But I know that r depends on t and h depends on t, so I can go ahead and turn this into a chain rule problem. Basically, I know that v is a function of r and h. I wrote it right there. And r is a function of t, and h is a function of t. Oops. F, G, can't use H, J of t. And so that's how I know this is a chain rule problem. And so if I want to find dv dt, my diagram should have v at the top. I write everything it depends on. That's r and h. And then those both depend on t. And then what's important to note here is in other examples, we knew what r was, and then we had to take the derivatives to get like partial r with respect to t. In this problem, we actually don't know what the radius is. We just know dr dt. All of these lines represent derivatives. And my paths to get from v to h are just all the paths on the diagram. This is really like the first example we did. Go from v to r to t or from v to h to t. And so the derivative of v with respect to t is going to be the product along both the paths. So the first path is dv dr times dr dt. And the second path is dv dh times dh dt. If v is equal to pi r squared times h, then I can go ahead and calculate dv dr is 2 pi rh, and dv dh is pi r squared. And hopefully you can kind of reason through that one, just like geometrically. It'll be good practice for you for the section that comes after our second exam. So dv dt should be partial of v with respect to r, 2 pi rh times dr dt. I knew that over here is just 3. And partial derivative of v with respect to h, was pi r squared. And then dh dt, I knew on the other slide, was just minus 5. Now at this point, I might have like this equation, and when I try to plug it into WebWork, it's all like, I don't know what r and h are. So we go back to our word problem and we say, oh, there's the stuff I never used. Oops, I wanted to change colors. So I never used that the radius is 10 inches and the height is 8 inches. And so I can go ahead and plug those in right here. Oops. So r is 10, h is 8, r is 10. We don't use h again. So that's 2 pi times 80 times 3 is times 240 plus pi times minus 50. That's 480 pi minus 50 pi. That's 430 pi. And then since this was a word problem, I'm going to be organized and write the units at the end. I'm trying to find the rate the volume changes with time. So volume is in units inches cubed. and per unit time is in minutes. And oh gosh, I made a mistake here. That was 10 squared. Sorry. So that should be minus 5 times 100, so minus 500. So my final answer wasn't 430, it was 480 minus 500, which is just negative 20 pi instead of whatever I had before. But that would be the final answer for this problem. I feel like I had to solve this problem in Stardew Valley once. So now you can do that too.